Okay, so the next part of our wave standard is dealing with wave behavior, specifically speed, as it travels through different medium of different densities. So this is like if we have a sound wave, we want to think about which type of medium is it going to travel through the fastest, to try to put them in order to rank them from which one's going to be the fastest. Okay, so for sound waves, it's going to travel fastest through a solid. We can remember this from doing the activity in class with our telephone that we made out of cups and string. Then after that, it's going to be liquid and gas. And then at the very end is a vacuum because sound cannot travel in a vacuum at all. All of this is dealing with the distance between the particles. Because remember, when we have sound traveling through something, it's because one particle is moving and hitting another particle, and it's going to do this easier and faster if the particles are closer together. So solids are mostly tightly packed, so they're going to travel faster. And then liquids and gases, as we go down, their particles are farther apart. Okay, so if we wanted to send a sound from one place to the next, what would be the fastest material to send it through? Steel, water, or air? So this one would be steel because our steel is a solid, and because it's a solid, it's going to travel faster. What about light? So this is a little trickier. So light, think about which one is going to travel fastest for light. Oops. So light, our fastest for light is actually a vacuum. You can think about light from the sun is traveling through the vacuum, and that's where it's happening the fastest. And then our light will then travel fastest through a gas, and then a liquid, and then through a solid. So this is backwards from what our sound is. And that's because the particles actually get in the way of our light because our photons are not atoms, so they are smaller so that they're able to go through. So the particles and atoms in the air are just going to get in the way. Okay, so what happens when light waves slow down or speed up? So remember, if some light goes through a different medium that is more dense or less dense, it can make the light waves slow down or speed up. And when it does this, the light starts to bend, the wave bends, and we're able to see all the different wavelengths of light. So this is like a prism. So this is refraction, where the light is bending.